Hey there, 8th graders, and welcome to today's Explainer. Get ready because today we are going to become math detectives. We're diving into patterns in square numbers, and our mission? Well, it's to find hidden clues tucked away inside perfect squares. You know, you can think of a perfect square kind of like arranging square floor tiles to make a perfectly even square room. And guess what? Numbers have these perfect patterns too. You are absolutely going to love how these simple little patterns can help you solve some seriously tricky math problems in just seconds. So here's our roadmap for today. First up, becoming a math detective. Then the last digit clue, followed by the odd number jump and the zero doubling trick. After that, we'll practice what you learned and finally wrap it all up with our final exam revision. All right, Section 1, Becoming a Math Detective. Every good detective knows you have to start by looking closely at the most basic clues. So let's look for some secrets in the basic numbers right here on this table. We have the numbers 1 through 10, and right next to them, they're squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on, all the way down to 10 squared, which is 100. Now, I want you to look very, very carefully at the last digits of these square numbers on the right side. We've got 1, 4, 9, 6, 5, 6, 9, 4, 1, and 0. Take a couple of seconds here. Do you spot a repeating pattern in those last numbers?
Section 2, the last digit clue.
Okay, if you looked closely at that last table, you probably noticed our very first major clue. The crucial thing to remember here is that a perfect square can only ever end in certain numbers. Look at the left side. Yes, a perfect square can only end with a 0, 1, 4, 5, 6, or 9. For example, 64 ends with a 4, 81 ends with a 1, and 225 ends with a 5. Those are all perfect squares. But take a look at the right side. No! Numbers ending in 2, 3, 7, or 8 are total imposters. They can never ever be perfect squares. If a number ends in a 2, like 52, or a 3, like 143, or an 8, like 278, you instantly know it's a fake. Just by checking that last digit, you can literally save yourself from doing so much complicated math on your next test. Moving right along, Section 3, the odd number jump. Awesome work so far, detectives. Now let's grab our second tool. This one involves looking at the distance, or the jump, between square numbers that are right next to each other. Let's walk through these steps together, nice and slow. Step 1, find consecutive squares. That just means numbers that come right after each other, like 8 and 9. So 8 squared is 64, and 9 squared is 81. Step 2, let's subtract them. 81 minus 64 equals 17. Now for step 3, look at that answer. 17 is an odd number. Okay, step 4, let's try it again, this time with 10 and 11. 10 squared is 100, and 11 squared is 121. Finally, step 5, subtract again. 121 minus 100 is 21, which, would you look at that, is also an odd number. So let's lock this pattern into our memory with a clear rule. The difference between two consecutive square numbers is always the next odd number. You can even think back to the smaller numbers to double check, like 2 squared is 4, right? And 1 squared is 1. 4 minus 1 is 3, which is an odd number. It literally works every single time.
Section 4, the zero doubling trick.
This next clue is honestly like a magic trick for numbers ending in 0, and it is going to save you so much time on your exams. Check out the number 10. It has just one 0, right? But when we square it, 10 times 10, it magically turns into 100, which has 2 zeros. So 1 0 becomes 2. And watch how this impact grows. Take a look at 100. It starts with 2 zeros. When we square 100, it becomes a massive 10,000. Count those zeros with me. There are 4. The pattern continues perfectly. Our 2 zeros just became 4 zeros. Let's summarize this rule nice and simply. If a number ends with n zeros, its square ends with 2n zeros. Basically, however many zeros you start with, you just multiply that amount by 2. 1 0 becomes 2. 3 zeros become 6. 4 zeros become 8. So, if you start with 5 zeros, how many will the square have? Yep, 10. It is a fantastic, super reliable shortcut.
All right, Section 5, practice what you learned.
Okay, time to put on those detective hats and test the clues we just uncovered. Here is your first question. Can 1, 2, 3 be a perfect square? I'm going to give you a quick beat of silence to think back to our very first rule, the last digit clue. And the answer is no. Just look at that last digit. It's a 3.
Remember our clue? A perfect square never ends with 2, 3, 7, or 8. Since 123 ends with a 3, we know for sure it is definitely an imposter.
Let's try another one. Can 576 be a perfect square? Take another beat to check that last digit. The answer? Yes, it might be. It ends in a 6. And since 6 is on our approved list, right along with 0, 1, 4, 5, and 9, it passes the initial test. And here's a fun fact for you. 24 squared is actually exactly 576. Do you see how fast this clue makes solving these problems? You don't have to do any heavy math. You just look at the last digit, and you're halfway there. Finally, Section 6, Final Exam Revision. You've all done excellent work today. Let's pull all our detective tools together to create the absolute perfect exam answer. I want you all to take a mental screenshot of this checklist right now. If your exam asks for the 4 properties of perfect squares, this right here is your model answer cheat sheet. Let's read through it slowly. 1. A perfect square ends only with 0, 1, 4, 5, 6, or 9. 2. It never ends with 2, 3, 7, or 8. 3. The difference between consecutive perfect squares is always an odd number. And 4. If a number has n zeros, its square has 2 n zeros. Keep these 4 rules in your head, and I promise you will do great. You all did an absolutely amazing job finding these clues today. But think about this. Now we know the patterns, but how do we actually find a perfect square using prime factorization? Well, that is exactly what we are going to uncover in our next lesson in Part 5. Until then, keep those math detective hats on, and thank you so much for joining me for this explainer. See you next time.